All right, guys, so here are our last two problems for this video. A little bit of just application, seeing where we use this stuff in outside the math classroom, right? So here's our first one. The arch of the Gateshead Millennium Bridge forms a parabola with the equation, there's your equation, y is equal to negative 0.016 times x minus 52.5 squared plus 45. And in this case, x is the horizontal distance from the arch's left end, and y is the vertical distance from the base of the arch. What is the width of the arch? Now, just to give you an idea of what's happening here, it tells us that x is the horizontal distance from the arch's left end. So that means 0 represents the left end of the arch. All right, so, our arch is wherever it starts there, and then however far out it goes, it ends at the same y value. Okay, so what we need to find is the distance from one end of the arch to the other end. Why did it do that? Oh, that's embarrassing. Sorry about that. I don't know why it decided to do that. We're not gonna connect that again. All right, so we wanna find, I'm gonna do it down here just to be safe. We wanna find this distance. Okay, now you might be thinking, okay, well, I don't know how to get that. Well, you know a few things, right? This is our vertex form. So we know that the vertex is right here, and it's h comma k. But then h in this case is 52.5, and k, sorry, is 45. So then it's 52.5, comma 45. So if I want to find the distance from one end to the other, well, if this right here, if this x value is 52.5, then that means this distance right here is 52.5. All right, because the x is the distance from the arch's left end. So when we're at the arch's left end, we're at 0. Okay, that's why the left end is all the way at the x equals 0 mark. All right, so well, if from here to there is 52.5, can you guess what this distance is then from the vertex to the other end? Well, it's symmetric, so it has to be the same distance, 52.5. So 52.5 plus 52.5, or 52.5 times 2, whatever way makes more sense to you. If you calculate that, that is 105. They give us units, so we want to use units. 105 meters. I'm just on a roll today, guys. I'm sorry. That is hideous. There we go. All right, hopefully that makes sense. And usually with these types of problems, you'll see that it forms the perfect parabola. All we need to do is take twice that x value of the vertex distance. All right, one last problem, and we'll finish the section 4.2 videos. The path of a kicked football is modeled by this equation. So we have, sorry, I can't see it. Y is equal to negative 0.026x times x minus 46, where x is the horizontal distance in yards, and y is the corresponding height. How far away is the football when it lands? Okay, well, same thing, we can model the situation kind of roughly. All right, notice how this is an intercept form. Now, it doesn't really show it, but since that x is there just by itself, that x is technically x minus 0. And then we have that x minus 45. And then to the left of it is our a, negative 0.026. So we know, since this is an intercept form, our P is 0 and our Q is 45. So then if here is 0 and here is 45, then we know that the parabola, it also opens down because it's negative in the front. We know it looks roughly like this. All right. So what is it asking us? You know, how far away is the football when it lands? Oh, sorry, this should be 46. Well, if y represents the height of the football in yards, okay, that's where my mistake was. Sorry, I knew something was going on. That's 46. That should be 46. That should be 46. My apologies. All right. 46. And then that's 46. Okay, sorry about that. So then how far away does it land? Well, it lands when the y value is 0 because our y is the height. Well, the y value is 0 here, but that's when we kick it. So then how far does it land? How far away is it when the height is 0? That part A is just x equals 46. Not too bad. So now part B, what is the maximum height of the football? Well, that's going to be at the vertex, right? That's going to be at the highest point. And in order to find that maximum height, that's the y value, because remember, y is representing our height. The first thing we need to do is find this answer. How far out is it at this height? So the x value. Well, remember, our vertex, the x value of our vertex is p plus q over 2. We add our two x-intercepts and divide by 2. Well, in that case, this is 0 plus 46 divided by 2. So that's just 46 divided by 2, which is 23. So it's, oh, here this should be 46 yards, sorry. So we know that the first part, or the how far is it out at this height? It's 23 yards out. And then the maximum height is whatever we get when we plug 23 into our equation. So y is equal to negative 0.026 times 23 for that first x, and then 23 minus 46. All right, so if we clean this up a little bit, negative 0.026 times 23. 23 minus 46, that's going to be negative 23. And then you just go ahead and use your calculator. So if we do 23 times negative 23, that's going to be negative 0.026 times negative 529. And then if we multiply those two things out, we're going to get roughly 13.75 yards. All right, hopefully that sounds okay. You know, to find the how far out, the horizontal distance, that was taking our x-intercepts, adding them up and dividing by 2, because that's our x value. And then our maximum height, that's plugging it back into the function itself, plugging 23, that x value, back into the function. All right. Hopefully that sounds good. And then I'll see you guys in the next set of videos.